So we have also gone through the galvanic series. So what tells you the galvanic series? It tells you about the corrosion behavior of the metals. Okay, so the metals which are placed in the bottom, those are more corrosive resistance, which are placed on the top, so more corrosive, right? Okay, so we will talk about some uh, passivation of the galvanic corrosion, and we will also discuss about how to control the corrosion and what are the factors affecting the corrosion. Okay, the passivation. So what do you mean by passivation? So passivation is a phenomena in which a metal or alloy exhibits much higher corrosion resistance than from its position in the electrochemical series. So it's called passivity. So that means so so there is a formation of highly protective layer on the surface of the metals. So this surface layer is very thin. So maybe very few microns. So on the surface of the metal or alloy. So which is corrosion resistant. That is called passivation or passivity. So it's also called passivation layer. Okay, so this passivation layer, so it is it's insoluble and it is non-porous and it has self-healing nature. So that means if there are some cracks on the surface, so it cures itself and it forms. So it will repair itself. So it's called self-healing. So it will repair itself on re-exposure to some oxidizing conditions. So that is called a passivation layer. So okay, for example, so these are the metals like titanium, aluminum, chromium. So this type of metals are widely used in the industry to protect the uh, metals. Okay, so this is another example. The action of more concentrated nitric acid on active metals like iron and aluminum. So produces a thin protective oxide, which is stable and which act as a analytic passive layer. Okay, so these passive layers a kind of protective layers on the metal surface. So the differences so far we have studied the dry corrosion and wet corrosion and the types of dry corrosion and wet corrosion. So what are the differences between dry and wet corrosion methods? So in dry corrosion method, the dry corrosion generally occurs in the absence of moisture, and wet corrosion it occurs in the presence of a conducting medium. So wet corrosion, what you call another name, it's electrochemical corrosion. So electrochemical corrosion in the sense, so it occurs only in the conducting medium. If it is not conductive, it may not occur. Okay. And dry corrosion involves direct attack of chemicals on the surface of the metals. And wet corrosion or electrochemical corrosion, it involves the formation of electrochemical cells. For example, we have studied if we bring if we connect two dissimilar metals. So there is one metal act as a anode, another metal is act as a cathode. So anode part is corrosive. So it forms electrochemical cells. Dry corrosion is a slow process and wet corrosion is a very rapid process. So once the electrochemical cells are formed, so the very rapid. The dry corrosion products are produced at the site of So whereas in wet corrosion, the corrosion products are deposited at the cathode. And in dry corrosion process, the corrosion is very uniform. But in the case of electrochemical corrosion, so it depends on the size of anodic part of the metal. So what are the factors affecting corrosion? So there are two. The one is the metals. I mean, what is the nature of the metal and nature of the environment? So nature of the metal and nature of the environment. So these two factors affect the corrosion. So let's go into metals. There are few. I mean, again, three types. So one is purity of. So when you increase the impurities in the metal, so there are there are more impurities in the metal present.
Sir, your voice is breaking.
So it can corrode more if there are or then it
Sir,
will. Okay. Yeah.
సార్ మీ
Yes.
వాయిస్ క్లియర్
Yes.
లేదు సార్ బ్రేక్ అవుతుంది.
క్లియర్గా లేదా ఇది? ఓకే, maybe I think signal problem. There is a power cut now. So I think network problem due to power cut. Is it okay now? Can you hear me?
Yes, sir.
Okay. So if it is a highly pure metal, so the corrosion of the metal will be less. So it is more resistive to the corrosion if it is high pure. So for example, zinc metal, so containing impurities undergoes corrosion of zinc. So due to the formation of electrochemical cells, and the rate and the extent of corrosion increasing exposure and extent of the impurities. Okay, the impurities and the pure metal so forms electrochemical cells, and there will be more corrosion. And the second type in natural metal and nature of metal is the position of metal in galvanic series. So you already know the galvanic series, the list of galvanic series. The metals are placed in the galvanic series. So based on their reduction potentials. So the metals which possess low reduction potentials, and occupy higher end of galvanic series. That means on the top. So they undergo corrosion very easily. So metals which possess high reduction potentials and occupy lower end of the galvanic series, they do not undergo corrosion and they get protected. For example, in the galvanic series in the previous slides, so the top one was the magnesium and magnesium alloys and copper, zinc, etc. On the bottom, there is platinum and some other noble metals. So the noble metals undergo less corrosion and which are placed in the bottom of the galvanic series. So that means they have high reduction potentials. Okay, so the position of metal in galvanic series. So that is the second type of the nature of metal, which is affecting. Okay, so when two metals are in electrical contact in presence of an electrolyte, then the metal which is more active undergoes corrosion. Of course, it's a natural. So as per our previous knowledge, Yes, so when two metals are in electrical contact in presence of an electrolyte, certainly there are two electrochemical cells are formation on the electrolyte, uh, which act as a, I mean, ion transport. So there is if, in that case, the metal which is more active, so certainly undergoes corrosion. And the rate of corrosion so depends on the difference in their position in galvanic series. If it is greater, then so the greater the difference, the more will be the okay. So if the difference in the position is more, then the corrosion, the extent of corrosion at the anode is more. Okay, for example, so the potential difference between iron and copper is nearly 0.78 volt, and the potential difference between iron and tin, which is 0.3 volts. So in that case, if you bring in contact with iron and copper, certainly will be corroded more than when you bring iron and tin together. So because there is a more potential difference between iron and copper. So on this account, so the use of dissimilar metals should be avoided. Different applications like screws and bolts and nuts to dissimilar the metals. So it's always better to avoid contact of these metals. So there is a third type is the relative areas of anodic and cathodic parts. So what do you mean by relative areas of anodic and cathodic part? Because when you bring two metals in contact, so one metal act as anode, another is a cathode. So there will be a difference between the area of anode and the area of cathode. In case if it is the cathodic area is very large, the rate of corrosion is very high. Right, so a small anode area and large cathode area, the rate of corrosion is large. So because anode, so the oxidation process, cathode is oxidation reduction process, right? So anode, so there will be more electrons are released. So cathode consumes the electrons. So if it is the cathodic area is very large, the consumption of electrons is very high. So that means so it will just extract the anode. So there will be more corrosion. So this is because the more electrons are liberated at smaller anodic area, so which are consumed at cathode, and the cathodic area is since it is larger, the liberated electrons at anode are rapidly consumed at cathode. So this enhances the anodic reaction. So that means so since the cathodic area is consuming more electrons, so it will extract the electrons from anode. Okay, so the when two dissimilar metals or alloys are in contact, so you can define the corrosion at anodic area is directly proportional area of cathodic part and inversely proportional to area of anodic part. Okay, so another type is hydrogen over voltage. So the difference between the potential of the electrode, so at which the electrolysis actually proceeds continuously, and the theoretical combustion potential for the same solution is called over voltage. So over voltage, hydrogen over voltage is nothing but the actual decomposition potential of the metals. So for example, so when a metal, so with high position in galvanic series, for example, zinc is placed in one normal sulfuric acid solution. So it undergoes corrosion with the deposition of a film on its surface and evolution of hydrogen gas. Okay, so when you take the zinc metal, when you dip the zinc metal in one normal H2SO4 solution, so there is a film formation on the surface of the zinc due to reaction with the zinc metal and the electrolyte sulfuric acid, and there is oxidation. So it evolves the hydrogen gas. The initial rate of corrosion is high since there is a it's a zinc metal is I mean it's pure, and sulfuric acid is corrodes. So the reaction is high in the initially, and the corrosion is, but it decreases after a while due to some salt formation, and there is a the film formation on the top of zinc surface, and also there is a hydrogen film surrounding the metal, so which causes high over voltage and reduces the corrosion rate. So the environment surrounding the metal, it changes because of the salt film and hydrogen film. So and it changes the surrounding environment. So and which causes high over voltage and reduces the corrosion rate. So when you then what is the relation between rate of corrosion and over voltage? It is inversely proportional. So it's a so over voltage increases, then the rate of corrosion decreases. So another example. So if a few drops of copper sulfate added to the corrosion, added to the zinc, the corrosion rate of zinc is accelerated because some copper gets deposited on the zinc metal, forming cathodes, where the hydrogen over voltage is reduced. Hence, the reduction in over voltage of the corroding metal accelerates the corrosion. So the higher the over voltage, the lesser the corrosion. If it is the over voltage is lower, then the corrosion is higher. So what is the relation between hydrogen over voltage and corrosion? It is a inversely proportional. So it's one if one goes up, another one goes down. So another one type is physical state of metal. The physical state of metal also uh, indicates the corrosion levels. The metals with small grain size. So small grain size means so the surface area is higher. So the surface there is more surface is available for attack if the grain size is smaller. So it will undergo more corrosion. And also some metals which undergoes more stress and strain, they also undergo corrosion very easily. The physical state of metal is also very important factor which indicates the corrosion behavior. So another type is nature of environment. So nature of environment also determines the corrosion levels. So for example, temperature. So temperature is always directly proportional to the rate of corrosion. If you increase the temperature, so there is more diffusion rate, then the more corrosion rate. And so if it is more humidity, certainly it's a more corrosion. So rate of corrosion is directly proportional to the humidity. And the effect of pH. The pH and rate of corrosion, the rate of corrosion is indirectly proportional to the pH environment. If it is a acidic medium, that means less pH, there is more corrosion. If it is basic medium, that means the pH is higher, the corrosion is less. So acidic pH increases the corrosion rate. So some metals like aluminum and lead so dissolves in alkaline solution as complex ions. Okay, some metals dissolves in acidic medium, some metals dissolves in basic medium. So based on that, the corrosion levels will be different. So if it is higher pH, so lower corrosion. If it is lower pH, or higher corrosion. So these are the factors are affecting the corrosion levels. So the nature of metal and nature of environment. So now how to protect these metals against the corrosion. So there are different types of protection methods of metals. So first one is the cathodic protection. So what do you mean by cathodic protection? So it's a cathodic this method is nothing but the protected or protection of the base metal. So by making it behave like a cathode, thereby corrosion does not occur, is called a cathodic protection. So you are forcing the to behave like a cathode. So you are forcing the metal, or you are creating the environment to the metal, so that the metal should act as a cathode. So it's called a cathodic protection. So there are two types of cathodic protection. So one is sacrificial anodic protection. Another one is impressed current cathodic protection. So let's come to sacrificial anodic protection. This is in this method, the metal is protected by connecting to a conducting wire. So the metal is connected to a conducting wire to a more anodic metal. The metal is anode, and it is connected to a wire, maybe platinum wire or some other conducting metals, so that all the corrosion is concentrated at, at the anodic metal. So that means the base metal, which is to be protected, that act as a cathode. So the conducting wire which is connected to the base metal is act as a anode. So wherever if there is some corrosive environment, so definitely the anodic part sacrifices, and it start corrosion. Anodic part is start corrosion, and the cathodic part, which is your base metal, that will be protected. So that means the corrosion is transferred from cathode to anode. So anode is the anode is a sacrificially protecting the cathode. That's why it's called sacrificial anodic protection. So where, so which you have connected your base metal, so it will start rusting itself. I mean, based depends upon the surroundings and the environment. Okay, the connecting wire it consumes, and the cathodic part, which is your base metal, that will be protected. So for example, so you see the diagrams here. On the right side, so the metal, for example, the base metal iron. So this is connected to a, okay. So the magnesium block, it is a sacrificial anode. Your base metal act as a cathode. If there is some if there is some oxidizing agents or corrosive environment occurs near the pipeline, so then the corrosion behavior, I mean, transferred to magnesium. So magnesium sacrifices, and it consumes, and it protects the iron pipe. So because this is an artificial anode, whatever you have called the magnesium block, so it protects the original metallic structure, which is your iron and pipeline. So hence the process is called the sacrificial anodic protection. So for this, mostly the metals, magnesium, zinc, aluminum, and this type of metals are already, I mean, are generally employed for sacrificial anode. Okay, so for example, even a ship. So when the ship is underwater, I mean, in water. So always the ships are in water. So there is a you should protect the metals which are used to for making the ship. So this in the ships there is a zinc on the dock block you can see. So it's a sacrificial anode. So it protects the base metal. So these are the applications which I have already seen. So by referring to the electrochemical series, the metal with the low reduction potential is connected to the base metal, which acts as a anode. And this sacrificial anodic protection method can be used to protect underground pipelines or buried pipelines separated by a magnesium block and even water tanks production of ship hulls and some other marine devices. I can use this sacrificial anodic protection method. What are the advantages? So it is very simple method and it does not require external power. It has a low maintenance and installation cost, and there are minimum cathodic interferences exist. And there are also disadvantages. What are the disadvantages? Because sometimes we may require more than one anode. So that is one disadvantage. And sometimes it does not work properly in high corrosive environment. That is one disadvantages. Another one is, so you have to periodically change this anodic metal, the sacrificial anode. So you have to change it because it is by time to time, so it will be consumed. So you have to replace it. So that is one another disadvantages with the sacrificial anodic protection method. So another method of cathodic protection is impressed current cathodic protection. So in this method, so for example, mostly used for underground pipelines in the soil. So the pipeline is connected to a another because base metal is a cathode in cathodic protection, and it is connected to a anode. So which is a where the anode must be insoluble. It should be very solid. It should not be soluble, and it is a gypsum or some other protective. I mean materials. Okay, so this anode and cathode are connected to external battery. Okay, so there is this cathode, I mean pipeline, is connected to a negative side of the battery, and positive side is connected to the your anode. Okay, so there is a power supply in that. Okay, this is called a source of impressed direct current. Okay, so based on the differences between the impressed current impressed current, so it will be protected against the corrosion. So in the corrosive environment. So in this method, the impressed current is applied in opposite direction to nullify the corrosion current and convert the corroding metal from anode to cathode. Okay, so if there is some corrosive environment, so then there will be inversion. So I mean anode, cathode act as a anode and anode act as a cathode. So due to the impressed current which is applied in the opposite direction of this cells. Okay, so the impressed current is slightly higher than the corrosion current. Then the anodic corroding metal becomes cathodic and protected from corrosion. Okay, so and the impressed current is taken from the it's a bad. So the metal to be protected is made cathode by connecting to an external battery, which is a negative terminal. The anode is usually insoluble, uh, like graphite or stainless steel or platinum, which is connected to positive. So which and there is a battery is connected, so which usually supplies the sufficient DC current. So in impressed current cathodic protection, so the electrons are supplied from an external cell so that the object itself becomes cathodic and does not get oxidized. Okay, so you should always need to have an external DC current for this method. For this method to protect the your base metal. The application is of this method is you can use in water tanks and some underground water or oil pipelines and transmission line towers. So what are the advantages and disadvantages? The main advantage is you can use this method to protect large structures of metals for long-term operations. But the disadvantage is it's very expensive, so it requires high current, and you need some capital investment uh, for uh, for this method. And it is very difficult to maintain uniform current so over the entire metal surface. As a result, localized corrosion may occur. So for the entire metal surface, you need to maintain uniform current. Otherwise, so there will be some localized corrosion. So the metal should not be over protected. So use of much high potential is avoided. Otherwise, problems related to cathodic reactions like evolution of hydrogen, formation of hydroxide ions takes place, so leading to corrosion of base metal. So if there is so over potential, so there are cathodic reactions may takes place and it releases the hydrogen and some hydroxide ions, so which causes your base metal corrosive. So this is called. So next is coatings, metallic coatings. Why metallic coatings? Because it's also very important of for metallic coatings to protect the metals against the corrosion, or to increase the resistance against corrosion. So in this case, you take your base metal. So on the base metal, you coat on with a different metal and film, a thin film of different metal. Could be some few microns size of film on the top of on the surface of the metal. So this is called metallic coatings. So these are broadly classified as anodic coating and cathodic coating. So for example, anodic coating. The metal used for the surface coating is more anodic. So that means so the whatever the metal used for to coat on the metal, so that is anodic than the base metal, so which is protected. Okay, so for example, so aluminum, cadmium, zinc on steel surface are anodic, so because their electrode potentials are lower than that of base metal iron. So this aluminum, cadmium, and zinc. I think you already have a patent. So hard dipping patent. This comes under this. So in metallic coatings. So therefore, anodic coatings protect the underlying base metal sacrificially. The formation of pores and cracks. So over the metallic coating expose the base metal and a galvanic cell is formed between the base metal and the coating metal. The coating metal dissolves analytically and the base metal is protected. So, so there will be a formation of pores and cracks on the top of the film, so which you coat on the metal surface. So it will this metal film and the as a and this galvanic the formation, so it protects the base metal. So another one is the cathodic coating. So in the case of cathodic coating, so you can obtain cathodic coatings are more with more noble metals. So that means the metals having higher electrode potentials like gold, silver, platinum, tin, etc. So this so it has higher electrode potential than the base metal. So the this method protects the base metal only when the coating is uniform and free from pores. Okay, so remember in the previous case even there are pores and cracks. So it works as a galvanic cell and protect the base metal. But here in this in the case of cathodic coating, so if there are pores and cracks, so you cannot protect your. So that's why. So you, to avoid pores and cracks, generally use noble metals. So noble metal generally it's you cannot. There are their films on the surface generally very smooth surface without any pores or cracks. So that's why. So it cannot enter. So this film doesn't allow to enter any chemicals to reach the base metal. So that means it's a so you can protect well. So hot dipping. So methods of application. So hot dipping is one method to apply your metallic coating method. Okay. So hot dipping is a process. So it's a method. So where you can achieve a metallic coating. So this you can apply to metals having higher melting point than the coating metal. Okay. So that means, so for example, if you want to coat on top of iron, so the uh, iron should have higher melting point than the lower melting than the metal you coat on top of it. Okay, so it is carried out by immersing a well cleaned base metal in a bath containing molten coating metal and a flux layer. So that means the you take a molten state. I mean the metal in molten state. That means it's a very you have to heat up the temperature the metal which is to be coated with base metal. So in the molten state of metal, so you take your metal rod, you can dip into that molten state liquid metal. So then take out, you cool it down. That means so the hot metal so is to coat it to your metal rod. This is called hot dipping, right? For example, when you take a salt, for example, take some sodium chloride, very high, or for example, I think it's not a best example. Uh, for example, cadmium and gold. So do you know gold jewelry? Okay, so in gold jewelry, so there are different types of metals, gold as well as copper. So you mix gold and copper at molten state. That means you heat up the materials, okay, and you make your ornament. But But this gold jewelry, sometimes we have to. There are some joints. You have to paste these joints with the different metal. So generally people, for example, hallmark gold, generally they use zinc. So they take the zinc, they heat up to high temperature and until it's a molten state. So and slightly they put this jewelry joint at this zinc, molten zinc. Then it will be solidified. Then there will be they connect the joints. Okay, so hot dipping is similar to that, but here you take in a, for example, in a vessel, in a pot, whatever, you take the highly boiled liquid metal. I mean, boil the metal in a liquid state. So you need very high temperature. Okay, then you dip your metal into this liquid metal solution. Okay, so there are two types here, the hot dipping process. One is galvanizing and tinning. Galvanizing, so galvanizing dipping and tinning. So galvanizing. So galvanizing is a process. So in which the iron article is protected from corrosion by coating it with a thin layer of zinc. So here thin layer of zinc means, for example, so first you take the zinc, you heat up until it melts. Then you take the iron rod, you dip the iron rod into your zinc and take it out. So that zinc is coated on top of. So it is the ionotic protection offered by the zinc. So in this process, the iron or steel is cleaned up by pickling with the whatever the steel or iron, whatever it is. So there is a lot of dust on the surface or some rust, right? So you have to clean up the surface. If you just directly take it, the I mean already dirty or rusty iron rod, dip into the zinc metal liquid, so you won't get a uniform thickness. So that means you won't protect it well, your iron. So you have to clean up iron. You clean up with sulfuric acid. So you take the sulfuric and you heat up the sulfuric acid at 60. It's not 900. It's a 90 degrees. Okay, 60 to 90 degrees. So he slightly heat up the sulfuric acid solution and you dip your iron into the sulfuric acid solution and take out and wash it with water. Then you clean up your surface. So after cleaning the surface, then you dip into your liquid zinc metal. Then the zinc is uniformly coated on the iron surface. So if you don't do this cleaning process, then you don't get good layer of zinc. That means, so if there is no good layer of zinc, certainly you won't protect the metal, the base metal. So that is the process here. Okay. So yeah, the article is washed well and then dried. So it is then dipped in bath of molten zinc. So maintained at nearly 430 degrees. Okay, so it is 430 degrees centigrade. It's not a 4300. Okay, it's a degree centigrade. So it took as a extra zero. Okay, the surface of bath is kept covered with flux to prevent oxide formation. So the article is covered with a thin layer of zinc when it is taken out of the bath. And then it is passed through a pair of hot rollers, which removes any excess of zinc and produces a thin film of uniform thickness. Then it is annealed and finally cooled slowly. Okay, so this is the process of galvanizing, galvanizing or the hot dipping. So there are two types of hot dipping methods: galvanizing and the thinning. So this is galvanizing. So this is the typical process of uh, hot dipping. See, I mean, these iron sheets are rod. Iron sheets are so rolled through sulfuric acid, diluted sulfuric acid, and the washing bath could be water, and then it is dried with hot air. So because it should, I mean, the surface should be very dry, for coating. So if it is wet surface, again you won't coat, you cannot coat uniform thickness. So then there is a molten zinc in another to and and it is rolled through a pair of hot rollers to remove the excess zinc, and it is annealed at again higher temperature. So maybe it's a less than the zinc molten state, the zinc melting temperature. Okay, it is called annealing. So if it is annealing at this process, so annealing status, so it is completely in this annealing step, there will be addition between your zinc and iron. So, for example, if you don't anneal it after coating, then maybe you may remove some zinc later on. So maybe the bond formation between zinc and iron may be less. So that's why you need to have a annealing process. When you anneal it, so there will be a perfect bonding between iron and zinc. Then you will get a stable, and it will be last for long term. So this is a galvanizing process. So what are the applications? So galvanizing is widely used for protecting iron exposure to the atmosphere. So these metallic sheets are not used for keeping eatables because of the solubility of zinc. Okay, zinc is soluble in many other things. So for edible items, okay, you cannot use them. So next process is tinning. So tinning is another process of hard dipping. So tin, so you can coat tin over iron or steel to protect from undergoing corrosion. So is known as tinning. So that means tinning means you coat tin metal. You coat tin metal on top of iron surface or steel. Okay, so this is a noble metal and it possesses more resistance to chemical attack. Okay, so in the previous case it was galvanizing. So you coat zinc on top of iron. So here in tinning, so you coat tin on top of iron or steel. So it is the cathodic protection offered by tin. So in this process, iron sheet is treated in diluted sulfuric acid to remove any oxide or any impurities from the surface. And a cleaned iron sheet is passed through a bath of zinc chloride molten flux, followed by molten tin, and finally through a suitable vegetable oil. So the zinc chloride flux helps the molten metal to adhere to the base metallic surface. And palm oil, so it protects the tin coated surface against oxidation. So finally, the sheet is passed through rollers to remove excess of tin and produce thin coat of tin of uniform thickness on top of your iron or steel articles. So this is the typical diagram for tinning method. So here you have to come from the right side, from the right to left. So first you clean it with the acid bath. You clean the surfaces and wash it with water. So then, so you have the seeds, the metallic are passing through molten tin tank, and then palm oil. Then you have to after palm oil, so you get the tin plated your metallic sheets. So this is the typical process of tinning. So what are the applications of tinning? The metal, the tin metal possess good resistance against. The tin is a non-toxic and it's widely used for coating steel, copper, and brass metals. So metal and metal alloys. Okay, the containers coated with the tin are used for storing foodstuffs, also ghee, oil, and packing food materials. The tin is a you can use because you want tin, you cannot dissolve it as like as zinc could be dissolved in some other metals or with so that's why you cannot use for food stuff for storage, but in the case of tin coated articles you can use for to store the food items. So tinned copper sheets are used for making cooking utensils and refrigeration equipments. So these are few things of our metal coatings. So there is another metal is metal cladding. Okay. Do you have any questions so far? Any questions? 45, 43. Seven. Okay. Okay. Good. Any questions? Any comments?
No, sir.